When discussing the concept of panspermia, the idea that life originating from one planet can be transferred through meteorites to another planet, one major aspect of it is that if that can indeed happen, which certainly appears possible, then almost certainly Earth has projected its microbial life in this way through impacts. It's effectively sneezed all over the inner solar system and beyond, and may well have landed on other solar system bodies that might offer habitability enough for microbes to get a foothold. This can, of course, include Venus and Mars ostensibly, but also ice shell moons like Europa and Enceladus. Who knows what gets churned below into the subsurface oceans as far as meteorites, potentially from Earth. And it's entirely possible that if we ever find life on or within any of these bodies, that life may not be alien, but rather a presumably distant cousin of Earth life originating from the same source, whatever that might originally have been. Indeed, we can't even demonstrate that life on Earth isn't a product of panspermia, and we are actually alien to this planet, particularly in regards to Mars. What if it started there and came here? We simply don't know. The reason for this thinking is that life on Earth seems to have arisen at the very earliest possible moment it could, perhaps suspiciously so, when the planet had calmed down just enough after its formation and the late heavy bombardment to allow it. Just as it did that, life appears. This could mean that life is straightforward as far as abiogenesis, and it's so easy that it just happens quickly. Or it could mean that life on Earth was deposited here from somewhere else, perhaps through a constant rain of meteorites from Mars in those days. Originating somewhere else can mean several possible things here, though. One is that, rather conspicuously, at the time that Earth came alive, Mars actually had been habitable for a bit longer of a time, by virtue of it cooling faster because it's smaller and becoming stable faster. At the time, it had plenty of liquid water, with Mars at the time seemingly presenting better, more stable conditions for abiogenesis than Earth was. It must be considered whether our life actually started on Mars, and it is our true home world. Sadly, the only way to determine if we are in fact Martians, however, is if life still exists on Mars, perhaps subsurface or in a moist lava tube. There we could study its genetics, and it would be evident if it originated from an earlier iteration of life that also spawned Earth life, and thus Mars must be the origin. Without extant life, it would be very difficult, but not impossible, to make a case for a Mars origin from fossil evidence alone. Almost certainly impossible from mere chemical evidence. But there are other possibilities, and another is that some other planet somewhat older than the planets of this star system with the Sun's original, then undispersed birth cluster, and that life on Earth started on another star system entirely, that is now far distant from us. It's possible that progenitor life, if it existed, still exists out there somewhere, and perhaps just as likely went extinct while we flourish here. Or perhaps it also spread itself elsewhere, and Earth has cousin life dotting the galaxy. But there's always been a question hidden in here. While it seems that a meteorite entering Earth's atmosphere could survive to hit the ground and spread life without much of a problem, what of the other planets? Would Earth life survive the fall into another atmosphere enough to disperse? Mars seems a solid yes, in principle. The only problem being, once it hits the surface, would it be able to withstand the dry conditions and the increased sterilizing ultraviolet radiation the surface of Mars sees, and the chemistry of the Martian regolith itself, which is hostile to Earth life, at least in its very uppermost layers? The answer to that is that it depends on just what period of Mars's history you're talking about. In the past, warm, wet Mars with liquid water probably could easily have seen it happen, and Earth microbes gained a foothold. Today, however, it does not seem likely that anything could hang on very long in the harsh environment, though it's not totally out of the question. But perhaps a bigger question would be Venus. Venus is a strange world because while it's unbelievably unforgiving and hot on the surface, it has a layer of its atmosphere that is perfect and presents the most Earth-like environment outside of Earth in the solar system as far as atmospheric conditions go. So could Earth life somehow have deposited in the upper cloud deck of Venus through panspermia without the surface being involved? This is the subject of a new analysis and paper by E.L. Guinan and colleagues, link in the description below, and they detail how that might work between Venus and Earth. Now, Venus is a strange world on the life count. We have all the hints Mars gives as for past life, and some indications of current, but certainly extremophile life. But Venus is different here in that every hint it gives of a potential biosphere would point to current active life in its upper atmosphere rather than the surface. Venus presents a number of hints. Most recently and famously was the detection of phosphine gas in the atmosphere of Venus. While phosphine isn't exclusively a gas made by biology, it is one of them. But Venus has been hinting at something going on far earlier than was worthwhile to investigate, going from the Venera probes of the Soviet Union detecting particulate matter of unknown origin at a certain level in the Venusian atmosphere that matched the size of bacteria, all the way to a mysterious unknown UV absorber present, again of still unknown origin. That might indicate the presence of microbial life very high up and away from the crushing heat and pressures of the surface. But Venus is not off the table as far as having hosted abiogenesis early in its history. In the distant past, it's thought it might have been an oceanic water world for a time that might have allowed for it. But the planet's proximity to the Sun prevented the long-term stability of that environment if it existed, and it evolved into what it is today. But it is volcanic, albeit in a little bit different way than Earth, and perhaps life arose there and has gone extinct on the surface only to have maintained a foothold in the temperate upper atmosphere, perhaps not even requiring water, but using droplets of sulfuric acid helped by a coating of certain molecules that might allow for it to metabolize in such an environment. You won't have birds here, but maybe very high altitude microbes. The paper goes into the harshness of Venus, presents unique challenges for panspermia to occur. You need for it to be possible for organic material to survive falling into the atmosphere of Venus, though there is a body of existing work that suggests that yes, it could actually happen. But the real trick is for the microbes to be dispersed in the upper atmosphere and cloud deck of Venus to even have a chance. If you go too deep on that planet, no Earth life traveling by meteorite will survive it. It has to be in the temperate zone. The modeling for this is a specific type of analysis model for how meteorites, bolides, pass through an atmosphere. Basically, you treat the bolide as a single fragmenting and ablating object, ultimately forming a pancake shape, which results in the object rapidly decelerating. It can then explode as an airburst, spreading even more fragments. The modeling looked at meteorites of masses in a variety of sizes. A lot depends on how strong the material actually is. Meteorites vary greatly in that regard. The weaker the material, the higher up the airburst tends to happen. They also looked at various concentrations of cells inside the meteorite and what's left after ablation and fragmenting of the main mass as it gets to the right height above the surface of Venus, where life could deposit in the temperate zone. What's left? It turns out that many billions of cells might get deposited by a meteorite into the cloud deck of Venus. Certainly most would not survive or find a foothold, but even if a tiny fraction of them did, it still represented billions of cells. Extend this over the multi-billion-year history of life on Earth, and many billions of tons of meteoritic material originating from Earth must have fallen on Venus, and very well could have deposited life on it, even as harsh as the Venus of today is. This may get complicated as there are private plans to do Venus LifeFinder missions and directly sample the temperate layer of Venus's atmosphere to see if there are microbes there. And if there are, then where are they from? Presumably this would require genetic testing, probably only doable here on Earth, to determine if the life, if Venus indeed has it, came from Earth or natively from Venus. One particularly interesting scenario would be if Venus life were found, and Mars life were found, and the life at Venus ended up not being from Earth, but instead originated from Mars. Or all three planets might have seen distinct abiogenesis events. And if that's the case, That it happens separately 3 times in a single star system would make a very solid case that the universe, at the very least, teems with microbes, seemingly if not intelligent life. The researchers note that the modeling is rather general, as bolides can be notoriously unpredictable, but it does show that in general, it's possible for at least Earth life to be deposited in the upper atmosphere of Venus. Whether it can get a foothold is another question. Sulfuric acid is not friendly to Earth life. An adaptation to it would somehow be needed. But it may also be possible that sulfuric acid, being a liquid, can be a solvent for life. The work there is still in its early stages as to figuring out how. But anyway, it will be an interesting next few decades as we try to unravel if anything lives in the clouds of Venus. Thanks for listening. I'm futurist and science fiction author John Michael Godier, currently wondering about interstellar objects. If you can have panspermia between planets, you should be able to have panspermia and rocks being exchanged with passing star systems. Such encounters occur regularly over geologic time. You have to wonder if some planet-bearing star system out there passed close, caught a meteorite from Earth, and out there somewhere are the cousins. Not likely for most interstellar objects, though. They spend billions of years in the interstellar medium. And be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.